So we are studying about the chapter number 3 of the class 10 science 1. So we are studying about the types of the chemical reaction. So till now we have studied the combination reaction and decomposition reaction. So in the combination reaction we have seen here the example of when ammonia reacts with the hydrogen chloride, there is the formation of the ammonium chloride. So as we can see here that when two or more reactants get combined, then that leads to the formation of the if that they leads to the formation of the single product, then that type of the reaction is called as a combination reaction. And we have also studied about the decomposition reaction. As we have studied here the example of the sugar, when heated there is the formation of carbon and hydrogen. As we can see here that 12 atoms of the carbon and 11 molecules of the water are forming in this type of the chemical reaction. So here we can see that one single reactant when gets broken down leads to the formation of the two or more products, then that type of the reaction is called as the decomposition reaction. So we have also seen about the experiment of that decomposition of the calcium carbonate. So we have taken the calcium carbonate, that is CaCO3, and when it is heated that leads to the formation of calcium oxide, which is in the solid state, and there is the release of the carbon dioxide gas. And when there is also one of the decomposition reaction at the hydrogen peroxide at the room temperature, that is the H2O2, at the room temperature get decomposes into the two products, that is the two molecules of the water and oxygen gas is released. So this we have studied. So also we have studied about the electrolysis process, as when that electrical current get passed through a water, then that water gets separated into the two form, that is the hydrogen and the oxygen gas is released. And as we have studied, also perform one experiment related with that in the lower classes, that is of the electrolysis with the help of the electrodes. So as we have seen there that the electrodes are getting occupied with the molecules of the hydrogen gas and the oxygen gas. So the chemical reaction in which two or more products leads to the formation of the single reactant. It's called as a decomposition reaction. So we are now going to see about the displacement reaction. So we saw in the beginning of this chapter that I'm adding zinc dust to a blue colored copper sulfate solution, a colorless solution of the zinc sulfate is formed. This also reaction we have seen above. See the equation 3 for this reaction. So the equation 3 which we have seen, so this reaction, that is the when copper sulfate, that is the aqueous solution, when zinc dust is added in that aqueous solution of the copper sulfate, then that leads to the formation of the zinc sulfate and the copper. So from that we learned that Zn2 plus ions form from the zinc atoms that takes place of the Cu2 plus ions in the copper sulfate, and copper atoms form from the Cu2 plus ions come out. It means that the Zn displaces the copper from the CuSO4. So the reaction in which the place of the ion of a less reactive element in a compound is taken by another more reactive element by formation of its own ion, then that type of the reaction is called as a displacement reaction. So as we have seen here, in the reaction of the zinc sulfate, zinc with the copper sulfate solution leads to the formation of ZnSO4 and copper solid form. So in this reaction, as we have seen that Zn is replacing the copper which is having in with the compound, that is the CuSO4. So Zn occupies the space with the sulfate and leads to the formation of the ZnSO4 and Cu is getting separated. So here we have seen what the displacement reaction is, that when the less reactive ion or the less reactive element in a compound get taken place by the another more reactive element by formation of its own ion, then that type of the reaction is called as a displacement reaction. We will learn about the reactivity of the elements in the chapter of the metallurgy. As here it is said that less reactive element get occupied with the another more reactive element by formation of its own ion. So we are going to see about the chart of the reactivity of the various different metals in the chapter metallurgy. The elements iron and lead, similar to zinc, displaces copper from its compound. So there we here we are having the complete the following with the help of the giving names of the product form after the completion of this reaction. So in the reactant side, we are having the copper sulfate as in the aqueous form. When reacted with the iron, which is in the solid state, leads to the formation. So there also will be the displacement reaction will occur here that the iron, which is having the less reactivity, more reactivity as compared with the copper. So here the ions of the ion will get formed and ion will form the compound with the sulfate that will be the FeSO4. So here will be FeSO4. So here will be the FeSO4 and the copper will get separated. Similarly with the copper sulfate plus lead. So basically the lead is denoted as the Pb because the scientific name of the lead is plumbum. So due to which it is written as the Pb when copper sulfate reacts with the lead, then that leads to the formation of the lead sulfate that is PbSO4 and uh, copper will also get released as the product. So this we have studied about the displacement reaction. Now we are going to see about the double displacement reaction. So we have seen in the equation 9. So equation 9 was, so here we have seen about the equation 9 that is the formation of the precipitate of the AgCl. So we are taking the silver nitrate and when we are reacting with the sodium chloride, so AgNO3 when reacts with the sodium chloride, there is the formation of the white precipitate of silver chloride and NaNO3 that is the sodium nitrate is formed. So what they are telling in the double displacement reaction, we will see about that. We saw in the beginning of this yeah, we have seen in the equation 9 that a white precipitate of the silver chloride is formed by an exchange of the silver and sodium ions present in these reactants. So, the reaction in which ions in the reactants are exchanged to form a precipitate is a double displacement reaction. So, here one important thing to highlight is that there is the formation of the precipitate. So, as we can see here, in the double displacement reaction, mostly there will be lead there that it is fixed that there leads to the formation of the precipitate in the product side. So that such a type of the reaction are called as a double displacement reaction. So recall the activity 3 in which you added potassium chromate that is K2Cr2O4 into the solution of the barium sulfate. So this also reaction we have seen. Here also there is the formation of the barium chromate and the potassium sulfate. What was the color of the precipitate formed? Write down the name of the precipitate. So this is one activity for you to perform and to see with that whether it is also following the rule of the double displacement reaction or not. Next part is of the endothermic and exothermic process and the reaction. So endothermic and exothermic heat is absorbed and given away in various processes and reactions. Accordingly, processes and reactions are classified as the endothermic or exothermic. Endothermic and exothermic processes. Heat from the outside is absorbed during some physical changes. For example, melting of the ice, dissolution of the potassium nitrate in water. Therefore, these are the endothermic processes. So basically, the word endo itself means that absorb. So here the word endo, basically it states it having the meaning that the heat will get absorbed. So when the heat gets absorbed in the chemical reaction, then that type of the reactions are called as an endothermic reaction. So here we are given the example of the melting of the ice. So melting of ice, so we can see that ice which is in the solid state. So after providing the heat to that solid ice cube, so it will get converted into the state of the matter water. So there that we can see that heat gets absorbed into the ice and the molecular force of the attraction which is present in between the atoms of that particular matter. So the bond gets break and that leads to the formation of the new product, as we have studied in the previous part also about the formation of the new ionic bonds and covalent bond, due to which there leads to the formation of the product. So here, after providing the heat, so heat will be get absorbed by the ice cube, and which leads to the formation of the product of water. So this type of the reaction we can say that as the endothermic reaction. Also, one of the reaction, that is the dissolution of the potassium nitrate in the water. Potassium nitrate, that we have seen, that KNO3, when we put that KNO3 powder into the water, so their heat gets absorbed into the as the potassium nitrate molecules gets the heat absorbed, and that type of the reaction we can also call this as the endothermic reaction. On the other hand, heat is given away during some physical changes. For example, formation of the ice from the water. So as we can see here that the heat when gets evolved or heat is given out, then such type of the reactions are called as the exothermic reactions. So here is having the example of the formation of the ice from the water. So as we have seen that melting of the ice, the heat we are providing to the ice cube, and in that if the heat gets extracted from the from that ice, then that leads to the formation of the water. So here we have seen the example, also the dissolution of the sodium hydroxide in the water. So NaOH, when we are adding it with the water, so that heat gets evolved or heat is given out in such kind of the reaction. So that type of the reactions are called as the exothermic processes or exothermic reaction. In the process of the dilution of the concentrated sulfuric acid with the water, very large amount of the heat is liberated. As a result, water gets evaporated instantaneously if it is poured into the concentrated sulfuric acid, which may cause an accident. To avoid this, required amount of the water is taken in a glass container and small quantity of the concentrated sulfuric acid at a time is added with the stirring. So if we directly pour, suppose we have taken the sulfuric acid and we have directly pour the water into it, then that leads to the sudden damage, as the huge amount of the heat gets evolved during such type of the chemical reactions. So as when the dilution of this concentrated sulfuric acid is done, that means we are using in the lab, that is the dilute sulfuric acid, dilute H2SO4. So that dilution is made by taking the small quantity and a, small amount of the concentrated sulfuric acid with the large amount of the water. So the solvent here we are taking as the water, which is in the large amount, but the solute which we are taking, that is the concentrated sulfuric acid. So we are taking it in the small amount, due to which the less amount of the heat gets evolved, and that leads to the avoidance from the damage. So about this also we have studied the same example in the class 8 also about the same exothermic process. To carry out the endothermic and the exothermic process. So here again we are having one experiment. So let's see, apparatus, two plastic bottles, measuring cylinder, thermometer, potassium nitrate we have to take, sodium hydroxide, water. Sodium hydroxide being corrosive, handle it carefully in presence of the teacher. So this is the activity which will be performed in the school labs as per according to your practical. So we will see what will be the conclusion of that all the activity which is performed. So during the process of the dissolution of the KNO3 in water, heat from the surrounding is absorbed and therefore the temperature of the resulting solution is less. The process in which it is absorbed from the outside is called as the endothermic process. When the solid NaOH is dissolved in the water, heat is given out and therefore the temperature increases. The process in which the heat is given out are called as the exothermic process. The same which I have told to you. That same theory is given here. Next part, endothermic and exothermic reactions. There is an exchange of the heat in the chemical reaction as well. Accordingly, some chemical reactions are exothermic while some are the endothermic. During exothermic chemical reactions, heat is given away when reactants are transformed into the product. While during endothermic chemical reaction, heat is either absorbed from the surrounding or has to supplied continuously from the outside. For example, as we have seen this reaction earlier also, that is the calcium carbonate. When we provide the heat to it, it leads to the formation of the calcium oxide and carbon dioxide gases evolve. So this is kind of the endothermic reaction. As the endothermic reaction, it is called because we are providing the heat, external heat to it. As we have seen that we are using the Bunsen burner for providing the external amount of the heat to perform this such type of the chemical reactions. So here we are providing the heat to the reactant, so that it classifies into the category of the endothermic reaction. So the next reaction, that is the calcium oxide when we add the water into it. So as we have seen here, the calcium carbonate when heat provided decomposes into the two products, that is the calcium oxide and carbon dioxide gas is released. So this calcium oxide, the product which is formed, we are taking that calcium oxide which is in the solid state. When we add the water into it, there leads to the formation of the calcium hydroxide plus heat. So this is basically the, as we can see here, the heat is getting evolved in the product side. So as we can see also, we can say that exothermic reactions are the reactions in which the heat gets evolved. So these are the two different reactions we have seen about the endothermic reaction and exothermic reaction. So we are having the question in the use your brain power. What is the difference in the process of dissolution and a chemical reaction? Does a new substance form when a solute dissolves in a solvent? So this we have seen also about, as I have told that we have seen the reaction of that is the dilution of the sulfuric acid. So as such that there is not the formation of the new substance at every time, because in the dissolution of the that sulfuric acid, we are taking the concentrated sulfuric acid as the solute and water as a solvent. So we are adding the solute in the minimum amount due to the that there is the exhaustion of the extreme amount of the heat. So that leads to the accidental damage. So as there formation of the dilution part of the sulfuric acid, but there is not such a new substance is getting formed. Rate of the chemical reaction. So take into account the time required for following processes. Classify them into the groups and give titles. So we are having the process of cooking gas starts burning on ignition. Iron article undergoes rusting. Erosion of the rocks takes place to form a soil. Alcohol is formed on mixing yeast in glucose. Solution under the proper condition. Effervescence is formed on adding baking soda into a test tube containing dilute acid. A white precipitate is formed on adding dilute sulfuric acid to barium chloride solution. So we have given here the various different processes and we have to classify them on the basis of the time taken by them. So as we can see here that ignition of the burner, that will be a quick process. But if we see here the iron article undergoes rusting, so it takes the years to years for getting an iron article to rust. So here, it can be seen from the above example that some reactions are completed in short time, that is occur rapidly, while some other require long time for the completion, that is occur slowly. It means that the rate of the different reaction is different. So from this, we can state about the rate of a particular reaction that is happening. So as we see that some reactions, that is the cooking gas starts burning on ignition, taking the slow time. Iron article undergoes rusting, taking the large amount of the time. So on that basis, we are defining the nature of the chemical reaction. So the same reaction occurs at a different rate on changing the condition. For example, during winter, long time is required for setting milk into the curd. So this is another one example that if we want to make the curd from the milk in the winter season, so it is taking the long time for making that. While at the higher temperature during the summer, rate of setting of the milk increases and the curd is formed early. But as compared with the summer, so to convert the milk into the curd, it becomes a short process that is does not take so long much time as compared with the winter season. So now let us see the factors which decide the rate of the chemical reaction. So we are going to see about the which are the factors that basically decides the rate of this particular chemical reaction. So factors affecting the rate of the chemical reaction. So firstly, the nature of the reactant. Let us see the reaction of the metals aluminum and zinc with dilute hydrochloric acid. On reaction of both aluminum and zinc with dilute hydrochloric acid HCl acid, H2 gas is liberated and water soluble salts of the metals are formed. However, the reaction of the aluminum metal takes place faster as compared to the zinc metal. So The nature of the metal is responsible for this difference. Aluminum is more reactive than the zinc. Therefore, the rate of the reaction of the aluminum with hydrochloric acid is higher than that of the zinc. Nature or reactivity of the reactant influences the rate of the chemical reaction. We are going to learn about the more about the reactivity of the metals in the chapter metallurgy. That is only the part that in the metallurgy chapter we will see how the reactivity of the various different metals is stated. But basically, the thing to understand here that when we are making the reaction of the aluminium with the dilute HCl, there leads to the liberation of the hydrogen gas. And when the same reaction we do that taking the zinc with the dilute HCl, there also leads to the formation of the hydrogen gas. But here we can see that the nature of the metal is responsible for the difference as Ai is more reactive than the zinc. So the reaction will be taking place faster at the faster rate with the help of the metal of the aluminium as compared with the zinc. So this is because of the as we can see that it depends on the nature of the reactant that taking place in the particular chemical reaction. Next is the size of the particles of the reactants. Again, we are having one experiment uh, that two test tubes balance measuring cylinder, piece of the Shahabat tile, powder of the Shahabat tile, and dilute HCl. Procedure takes pieces and powder of the Shahabat tile in equal weights in the two test tubes. Add 10 ml dilute HCl in each of the test tube. Observe whether effervescence of the carbon dioxide is formed at a faster or the slower speed. You must have found in the above activity that the CO2 effervescence is formed slowly with the pieces of the Shabat tile while at the faster speed with the powder. The above observation indicates that the rate of the reaction depends upon the size of the particles of the reactant taking part in the reaction. Smaller the size of the reactant particles, higher is the rate of the reaction. So this is again one of the important thing as it's basically asked in the activity part in the exam that smaller the size of the reactant that smaller will be the size of the reactant particles, higher will be the rate of the reaction. So this is the thing that to remember. If we are taking the Shabat tile as a whole piece, so it will obviously take the more time for the completion of the reaction and releasing of the effervescence of the CO2. But if we break down that into the smaller pieces or as a, in the powder format, so the reaction will happens at the larger rate. So as we can see that the size of the particles of the reactants also acts as the one of the factor for the plays an important factor in the role of for the rate of the reaction. Next we are having the C part, that is the concentration of the reactants. Let us consider the reaction of the dilute and the concentrated hydrochloric acid with CaCO3 powder. So we have to do the reaction of the calcium carbonate with the dilute HCl and concentrated HCl. Dilute HCl reacts slowly with the calcium carbonate and thereby calcium carbonate disappears slowly and CO2 also liberates slowly. So if we are making the reaction in the presence of the dilute HCl is having the some amount of the water is added slowly with the calcium carbonate and thereby calcium carbonate disappears slowly as CO2 also liberates slowly. On the other hand, the reaction with the concentrated HCl takes place rapidly and COCO3 disappears fast. But if the same reaction is going to happen with the concentrated HCl, then that we can see a sudden change of that calcium carbonate disappears fast and there is the fast release of the carbon dioxide gas also. So, as we can see here, concentrated acid reacts faster than the dilute acid. So, again, one more thing to remember that concentrated acid reacts faster than the dilute acid, which means that the rate of the reaction is proportional to the concentration of the reactant. That the reactant which we are taking in the particular chemical reaction, so the rate of the reaction also depends on the concentration. As we have seen that dilute HCl is reacting slowly as compared with the concentrated HCl. So from this also we can state that uh, the rate of the reaction also depends on the concentration of the reactants. Next part is the temperature of the reaction. While studying decomposition reaction, you carried out decomposition of the limestone. In this activity, the lime water does not turn milky before heating the limestone because of the zero rate of the reaction. From this, it is learned that the rate of the reaction increases on increasing the temperature. So we are talking about the reaction of the decomposition of the limestone that we have seen that CaCO3 when provided with the heat leads to the formation of the calcium oxide and the carbon dioxide gas is released. So that in that reaction, as we have seen that the heat, if we provide the less amount of the heat, so the reaction is taking at the slow rate. But if we increase the rate of the heat providing, so as the temperature of the reaction gets increases, then that leads to also the faster rate of the chemical reaction. So here the temperature of the reaction also plays an important role in the on the rate of the particular chemical reaction. Next, that is the catalyst. On heating potassium chlorate KClO3 decomposes slowly. So KClO3 when provided with the heat leads to the formation of KCl and oxygen gas is released. Rate of the above reaction neither increases by reducing the particle size nor by increasing the reaction temperature. However, KClO3 decomposes rapidly in presence of the manganese dioxide MnO2 to liberate O2 gas. No chemical change takes place in the MnO2 in this reaction. So basically, when we are studying about the decomposition of the KClO3, we can here observe that KClO3, the reactant, when provided with the heat, leads to the formation of the potassium chloride KCl and oxygen gas is evolved. But here we can see that this reaction does not happens at the faster rate as we are taking if we are taking the KClO3 particles reducing its particle size and all, suppose we are increasing the amount of the heat provided and all, but the reaction is taking at the slow pace. So to increase this rate of the reaction in this particular, so we have to add here the catalyst. So here we are adding the catalyst, that is the magnesium dioxide. So if we add the magnesium dioxide as the catalyst in this reaction, so the rate of the reaction will also increase. No chemical change takes place in the MnO2 in this reaction. So what is basically the catalyst? So catalysts are the basically the substances which takes part in the chemical reaction but without change the chemical composition of that particular reaction. So here we are given also the substance in whose presence the rate of the chemical reaction increases without causing any chemical change to it. It is called as the catalyst. Again, this is the important definition as perspective of the exam also. It may ask the decomposition of the hydrogen peroxide into water and the oxygen takes place slowly at the room temperature. However, the same reaction occurs at a faster rate on adding the manganese dioxide MnO2 powder in it. So, also we have studied about the reaction that is the decomposition of the hydrogen peroxide, that is the H2O2. H2O2 at the room temperature when decomposes leads to the formation of the H2 and O2. So if we consider this reaction happening at the room temperature, so this reaction happens at the slow pace on the if we are performing it at the room temperature. But if we add the catalyst named as the manganese dioxide in this reaction, then that will increase the rate of the reaction of decomposition of the hydrogen peroxide. So this is the part that the catalyst act as an important plays an important role in the increasing the rate of the particular chemical reaction. So we have seen here the catalyst as the magnesium dioxide, but we have seen above one reaction that is the vegetable oil. There is also acting of the one catalyst which may ask in the exam about that particular reaction. So we will see about that. So here is the reaction number 6, that is vegetable oil reaction with the hydrogen gas in the presence of 60 degrees Celsius and nickel catalyst. So we are adding the nickel as the catalyst here. So basically nickel is also acting as playing a role of the catalyst. It is taking the part in the it is basically increasing the rate of the reaction but does not making any of the chemical change in the particular reaction. So this we have seen about the catalyst. The remaining next here we are having the do you know. So first is one or more chemical reaction takes place during every chemical change. Some chemical reactions occur at the fast speed whereas some occur at the slow speed. Strong acid and strong base react instantaneously. In our body, enzymes increases the rate of the physiological reactions. Perishable foodstuffs gets preserved longer in the refrigerator. The rate of the decomposition of the foodstuff gets lowered due to the low temperature, and its freshness is maintained. Vegetables cook quickly on oil rather than on water. The chemical reactions are profitable in the chemical factories if their rate is fast. The rate of the chemical reaction is important from the environmental point of view as well. The ozone layer in the Earth's atmosphere protects the life on the Earth from the ultraviolet radiation of the sun. The process of the depletion or the maintenance of this layer depends upon the rate of production or disruption of ozone molecules. So next we are having the oxidation reduction reaction that we will be seeing in the next part. And we are having one final, the concept of the corrosion. So that we will be seeing. And also one important concept of the rancidity.